In this video, we're going to talk about trigonometric techniques of integration. And the integral that's going to be, the first example, is going to be the integral of cosine x sine quadrupled sine of x dx. So to find the antiderivative, you will use the u substitution. And the u is going to be sine. And how do I know that it's going to be sine? Is because the du is going to be the derivative of that, right? The du is going to be the cosine. The derivative of sine is the cosine. Okay, so cosine x dx. So that we can have sine for x. So we can say that this is u to the fourth, right? Because sine is quadrupled. And then cosine x dx is the du. Okay, so we're going to have u to the fourth du, simple as that. And that's going to be 1/5 the antiderivative, 1/5 u to the fifth plus a constant, substituting back to the trigonometric function of x. We will have 1/5 sine 5, right, x plus a constant. Okay, so sine x is raised to the fifth power, and also using the antiderivative rules, the power rules, you should know that we will divide by the resulting power of u, and that means that we will have 1/5 as the coefficient. And then we substitute back the u in terms of the sine x, right? Now the second example is going to be a little more complicated, because here the integrand will be cosine squared dx. And as you can see, you can't determine the antiderivative directly like this because there's no du if you try to use the u substitution. However, you can write this cosine squared x using the half angle formula for the cosine squared x, which is going to be 1/2 cosine 1/2 times 1 plus cosine 2x dx. Okay, so this is the formula for the cosine squared x, the half angle formula. So that should be easy now because you can basically distribute. So you will have 1/2 plus 1/2 cosine 2x dx. Okay, so then you will have the 1/2 is a constant, so we will turn to 1/2 x, right? And then you can use the u substitution. U is equal to 2x. The du is going to be 2 dx, right? So you can write it as 1/2 cosine u, right, du. But since there's a du that's 2 dx, that means dx is going to be du over 2, right? So we have to have a 1/2 added there as well, right? We have to divide it by 2 because dx is equal to du over 2. If you want to substitute the dx in terms of du, du will be divided by 2. And don't be thrown off by this 1/2 there, right? It's still, that 1/2 existed there originally, right? But since we have a du in there that didn't exist, we have to divide by 1/2 to compensate for that 2 that popped up in the du. Okay, so then we're going to have 1/2 x plus 1/4 now cosine u du. And that turns into 1/2 x plus 1/4 sine u plus a constant, right? And that's going to be equal to, and why is it sine? Because the antiderivative of cosine is sine, right? You can check it back with differentiation that the derivative of sine is cosine, right? So it's going to be 1/2 x plus 1/4 sine. Now what is u? U is equal to 2x, right? So it's going to be sine 2x plus c. So that's your antiderivative. Thanks for watching this video, and I'll see you in my next one. Please subscribe to my channel. Thank you.